Hello, welcome to Marsh Mathematics, and this is the second video on points of inflection. Now I'm going to do two examples and this is the first one. Right, in green I've just summarized what you need to know about stationary points of inflection and non-stationary points of inflection. Okay, and these are the two. In red is how we check whether it's a point of inflection or not. Okay, so we've got this example here and we want to know, it just says find the points of inflection. Okay, so first of all we find dy by dx, then the second derivative. Okay, now for points of inflection, d2y by dx squared has got to equal 0. Okay, that's the first thing for a point of inflection. So we make it equal to 0 and we find out that we solve that and we find out that x equals 0 or x equals 1. Now what we've got to do now is to check whether they are points of inflection. Okay, because it's true that d2y by dx squared is equal to 0 for a point of inflection, but it doesn't necessarily have to be a point of inflection. Okay, so what we do is we check either of these. Okay, so when x equals 0 we find that dy by dx is equal to 0, so that means it's a stationary point as well. So we'll look either side of x equals 0 and we find that dy by dx actually changes. So this, by checking this, we find out that x equals 0 at x equals 0, it's actually not a point of inflection, it's actually a maximum point. Okay, so at a maximum point, but at this point you see d2y by dx squared is equal to 0 as well. So it doesn't have to be a point of inflection if d2y by dx squared is equal to 0. We did this in the last video. Okay, so it is a stationary point, and also d2y by dx squared is equal to 0, but that doesn't mean to say it's a point of inflection, because it's actually, because we can check that by how dy by dx changes. This is the number one way to check it. Sometimes you can do this one, you can use this second method, but most of the time by checking how dy by dx changes or doesn't change, we can decide whether it's a point of inflection or not. So the first point, x equals 0, is a maximum point. Now if we check out the next point when x equals 1, we find that dy by dx is, we find out that when x equals 1, you see dy by dx is not equal to 0, it's equal to -4, so it's non-stationary. But is it a point of inflection? Well, we'll check. Okay, we'll check and we'll find out that either side of x equals 1, we find that, you know, if we just put in x equals 0.5, x equals 1.5, we find that dy by dx does not change. And so x equals 1, and we put into the original equation, we get y equals 0, is a point of inflection. Okay, and it's non-stationary because dy by dx does not equal 0. Now I've gone on to Desmos. Desmos is a really useful thing to be able to check your graphs if you're doing examples, and we'll find out if we just plot the graph there, we can see what's happened here. We can see that this is our maximum, and you notice where it's flattened. That's because d2y by dx squared is equal to 0 as well as dy by dx is equal to 0. Okay, here dy by dx is not equal to 0, but d2y by dx squared is equal to 0, and this is a non-stationary point of inflection, a non-stationary. Okay, point of inflection. Right, so I hope that's okay. Now I'm going to do another example, and I write these out so that I can talk through them and get through more examples in a shorter space of time. Now just look at the black writing at first. Okay, so it says find and classify the stationary points on this curve and then sketch the curve. It didn't ask to sketch the curve next in the last one, but this one is, and this is quite a difficult question. There's a lot of working in this because okay, we have to find out the stationary point. It doesn't tell us there's any points of inflection, but if you're going to get a second year question, there'll normally be a point of inflection. In the first year you won't get that, it'll just get maximum and minimum points. Okay, so okay, the first thing we do is differentiate it and make dy by dx equal to 0 for stationary points. Now we notice now that this doesn't factorize quite as easy, so all we can't try to factorize that. It's it's quite difficult to try and guess it. So what we do is we just sort of by inspection we guess that one of the roots or one of the solutions is x equals 1, and it is. So we have to find out and guess that. So that's the first thing that's quite difficult, is just by inspection put values into this until you get one of them equals to 0, and so we know that x minus 1 is a factor. Then we can divide it in using this process. Okay, so there's a lot of maths in this, and then we can actually get this. We can go from here all the way down to here, you see, and then we can factorize it, and then we're going to get x equals 1 and x equals, so it's a double root, okay, and then x equals minus 5 over 4. Now we get a weird answer for y, but that's okay. So we've got 2 points here, and then we have to find out what they are. They are stationary points. So what type of stationary points are there? So we find the second derivative. So look at the red writing now, and we've got d2y by dx squared is this. When we put x equals minus 5 over 4, it's nice and easy this bit, because we get d2y by dx squared is greater than 0. So that is a minimum point, okay? So that is like a first year question. But when we put x equals 1 in, we get d2y by dx squared is equal to 0. So is it a point of inflection? It could be a maximum or minimum like the other question. So what we do, we look either side of x equals 1, and so either side of it is x equals 0.5. We define dy by dx is greater than 0, and the other side of 1, x equals 1.5, we get dy by dx is greater than 0 again. So dy by dx, the sign of it does not change, so it must be a point of inflection, and dy by dx is equal to 0 there, so it's a stationary point of inflection. Okay, so there's a lot in that. I know I've talked through it quite quickly, but it's a really good question. And to sketch the curve, you see, there it is. Okay, so there it is, and this is a minimum point here, and this is your stationary point of inflection. Okay, and so there we have it. Two really good questions there, and just look through it. If you can answer those two, you understand those two questions and go through them, you'll be really fine for any sort of examination questions in this area for year 2. Okay.